The first lessons in Module 2 are 18 and 19, called Properties of Rotations, Reflections, and Translations. And the objectives are to perform and understand 3 types of rigid motion. So there's a lot of vocabulary in these 2 lessons. The first vocabulary word is rigid motion. What rigid motion is it changes the position of a figure without changing its size or shape. Examples of rigid motion are rotations, reflections, or translations, and that's what you'll be learning in this lesson. So when you think of rigid motion, think of you taking your iPad, which is a rectangle, and you just change the position. So you either rotate it around, you reflect it, you flip it over, or you translate, or you slide it around. Your iPad is still going to be the same size and the same shape. So rigid motion is being able to move an object without changing the size or the shape. Next word is congruent figures. Have the same shape and the same size. And here's the symbol for congruent figures. It's an equal sign with a kind of a squiggly line over top of it. It means the exact same thing as equals, but it's more for shapes rather than numbers. And then next we have a sequence of rigid motions can be used to move one plane figure so it coincides with another. This is how you prove they have the same shape and size. So coincides means you're just able to trace one figure and then rotate it, reflect it, and when you trace it again, if you were to match them up perfectly, it would lay right on top of what you traced. So coincides means you're able to just move it over top and it's going to have the same shape and it's going to have the same size. And you can use rotations, reflections, and translations. Those are our 3 rigid motions to prove that 2 things are congruent, and that's what we'll be doing down below. Next vocabulary word is image. It is the new figure that matches the original figure. So imagine that you took your iPad up to the board and you just traced it. That would be your original figure. And then you move your iPad somewhere else and then you trace it. Your second picture of your iPad would be called your image because that's the new figure that matches with the original. And the next vocabulary word is, it's not really a word, it's more of a symbol, the prime symbol. It just looks like an apostrophe. So if you're labeling your drawings of your iPad, your original figure could be marked with the letter A or any letter that you want. And then the image, the second one, is going to also be A so that you know they match, but it's going to have the prime symbol on it so you know that that was the second one. It just tells you the order that you did your steps in, so you're not saying left to right instead of right to left. Now we will go through each of the 3 types of rigid motions. The first one is a rotation. So another word for rotation is a turn. It's a turn of a figure around a specific point. So right now, if you're watching this on your iPad, hold down one corner of your iPad and just start spinning it around your finger. That would be a rotation around a specific point. So you can rotate 2 directions. You can rotate clockwise, which is the same direction as a clock, to the right, or counterclockwise, which is the opposite direction, which would be to the left. When you describe how you rotate, you're going to have to say how far you rotated or how many degrees. So 360 degrees is a full circle. If you do a flip, if you're into gymnastics and you start with your feet on the ground, you have to go all the way back around for your feet to be on the ground to do a full circle or 360 degrees. 180 is half a circle. So if you're doing a flip, you could start on your feet and you would land upside down, either on your head or if you put your hands down first. That's half a circle, 180 degrees. And then the last one is 90 degrees, which is 1/4 of a circle. Or just think of, if you know what a right angle looks like, if you draw a right angle and you go from one line to the other line, that would be in between those 2 lines is 90 degrees. Okay, so here are some examples of rotations. We'll go through, the answers are already at the bottom, but I'll go through and show you how we got what we decided the answer was. So the first thing you have to do is mark which one is the original and which one is the image. So instead of writing everything out, I'm going to put O for original and I for image. Well, I know this one in blue is the image, because of the prime marks on the T, the H, and the Y, which means the one in black must be the original. Okay, so you're always starting with the original and you're rotating to get the image. So the best thing I think to do is to pick one of the corners or pick one of the letters. So if you pick Y and you highlight Y, find the corresponding corner, which would be Y prime. Now, it looks like this triangle was rotated and it's upside down. The original Y was on the top and now it's on the bottom. So if you need to figure out the arc or how many degrees it was rotated, sometimes it helps to actually draw the arc. If you draw this half circle in, okay, so you can see that it was spun upside down. What was on the top is now on the bottom, and if it was 100, if it's upside down, that's 180 degrees. And you can see that we've drawn half a circle here, not a full circle, just half a circle. And sometimes it's easy if you have a coordinate plane, which we do here. You don't always, but if you have a coordinate plane and you look at the x-axis and the y-axis, it breaks it into 4 quadrants, which are each 90 degrees. So if sometimes it helps to just count by 90. So if you moved Y, if you moved it 90 degrees, you would move it 1 quadrant. So it would be in the next quadrant. Well, that's not where our final figure is, so we moved it from there to the next quadrant. So each set of 90 plus 90 is 180. Now, when you go 180, the way we drew it, the way I drew my arc, was in the same direction as a clock. So that's why I put down here as the answer, rotated 180 degrees clockwise. But you could also draw your arc the other way if you wanted to, and that would be 180 degrees counterclockwise. So in this case it doesn't matter, but you should say the word, you should say what you did. So we said that we rotated. You should say how many degrees. We said 180, and you should always say which direction, clockwise. So those are the 3 things you need to say for any type of rotation. Okay, we'll move on to example 2. First thing you want to do is label which one is the image and which one is the original. So I see the prime marks up here on B and F, so that means this is the image. This was the second figure, and the one here in black was our original. So now, figure out how we rotated. So just some advice, it's probably, if you're going to pick a letter, you don't really want to pick F, because it's kind of overlapping and it's in between, and it's just, you want to pick something that kind of sticks out and it's on the outer side. So something like M to M prime. There's not a lot of clutter there, and you can see which direction you rotated. So if you look, it looks like this quadrilateral was rotated. It was kind of spun on it was kind of up. If you look at, I mean, sometimes these are hard until you actually start moving these figures around, but if you look at this specific line from M to H, it's going from left to right. And if you look at M prime to H prime, it's going up and down. So you can tell that it was spun, and then now you have to figure out how many degrees in which direction. So if you make an arc from M to M prime, or if you just look at the lines, that's how you get that it was spun 90 degrees, because it went 1 quadrant. And which direction are we going? We're going the direction of a clock, so we're going clockwise. So our answer was rotated 90 degrees clockwise. Now, there's another answer here. If you want to go from M and you want to go the long way around and you want to go this way around to get to M prime, that would be the other half, that would be the other part of the full circle, which would be 270 degrees counterclockwise. Either one is a good answer. I usually go with the one that is smaller. I usually go with 90 over 270, but they're both correct answers. Okay, number 3, if you want to, we'll mark down which one is the image and which one is the original, and then if you want to try and draw your arc and figure out the degrees, see if it matches what it says below. So I see the prime marks on this one over here in blue, so I'm going to put an I inside that one. That one is the image, which means the one over here in black is the original. So go ahead, it looks like it was rotated. Now we're also going to do reflection, which is a flip, and this one could have been flipped, except for the fact that when you flip something, whatever was on the top stays on the top. It's just kind of flips left to right. So I know this was rotated because if you look at T, it's on the bottom, and if you look at T prime, it's up there on the top. So this was turned upside down, and turn is a rotation. So go ahead and draw your arc and see if you end up getting 180 degrees. And then move on to number 4, and we'll mark the image and the original. So the image is here in red because of the prime marks, and the image is in gray. So we took the gray shape and we rotated it, and we got the red shape. So if you want to pick out a letter that kind of sticks out, that's not in a lot of the clutter, I would say G and G prime. So figure out how G was rotated to get G prime and then come up with the direction. Okay, our second type of rigid motion is called a reflection. And a reflection is a flip of a figure over a point or a line. It's like looking in the mirror. Okay, so here are some examples of reflections. Now, before you do these, sometimes it helps if you stick your hand out and look at your fingers and stick your thumb out so it makes an L. Now, rotate your wrist and flip your hand over. Your fingers, your fingernails are still going to stay at the top, but your thumb is going to flip from the left side to the right side. So it's different than a rotation because nothing is necessarily going upside down. So as we do more of these, you'll have to pay attention whether it's turning upside down or if it's just flipping from left to right. Okay, so the examples say, describe how each original was reflected to make the image. Okay, so let's look at number 1. So again, mark down which one is the original and which one is the image. So the one with the prime marks is the image, which would be the blue one, will be I, and then the original was the black. And then do the same thing, pick a letter, and then find the corresponding letter. So we could go with K and K prime. So you see it's still on the bottom of the triangle, so it wasn't rotated upside down, it wasn't on its side, it was just flipped. If you look at the pointed part of the triangle, K was sticking out to the left, and now K is sticking out to the right. So it was a reflected. Now, when you describe a reflection, you have to describe what it was reflected over, which would be the line of symmetry. And what the line of symmetry is the halfway point. What you reflected it over, you should have the same amount of space to the left of that line and the same amount of space or blocks to the right. So this one is pretty easy because there's 2 blocks between these 2 triangles. So a lot of times I'll draw a dashed line down the middle, and that's the line of symmetry. So when you describe it, we'll say it was reflected over, and then this line, it's not the y-axis, it's nothing really special, it's just a vertical line, but the line is vertical, so you want to say it was reflected over a vertical line, because reflecting something over a horizontal line is going to look a lot different. So that one is reflected over a vertical line. Number 2, let's do the same thing. I'm going to mark the blue one as the image because of the prime marks, and the black one is the original. I'm going to pick a letter. This time I'm going to pick X, so X and X prime, and it doesn't matter which letter you pick. So you can see, you can tell that it was a reflection. Even if you look at F and F prime, sometimes you need to look at more than one letter to decide what happened. Again, one is sticking out to the left, one is sticking out to the right, so it was just flipped over. So this is a reflection. Now, usually the point that's in the middle, that would be closest to the line of symmetry, is what's going to help you most figure out where you want to draw your line of symmetry. So if I look at G and I count the blocks between G and G prime, I'm actually going to start at G prime. So and I count the blocks, 1, 2, 3, 4 blocks in between. So halfway between that would be 2 blocks on each side. So if I draw my line of symmetry 2 blocks in the middle, you can also check with X. Now it's not going to be 2 blocks because it's not as close, but there is 1, 2, 3 on the left side and 3 on the right side. So it's also in the middle of X. And then you could check F, but you don't have to. So when you describe this, you're going to say reflected over. Now this is a vertical line, but it's a very specific vertical line. It happens to be the y-axis. So when you can be more specific, it's always better to be more specific if it's reflected over the X or the y-axis. So reflected over the y-axis. Now we have number 3. So the blue one is going to be the image because of the prime marks, and the black is the original. If you look at kind of the whole picture, you can tell it was reflected because we have, let's see, we have line BU over on the left, and now BU is over on the right. S is still on the bottom, so it wasn't flipped upside down. It wasn't turned upside down. It was just reflected. So this one's a little tougher to find the line of symmetry because it crosses over itself. But if you look at M and you draw your last dashed line halfway down through the M's, the pink line there would be the line of symmetry. So nothing special about that line. It's just reflected over a vertical line. And number 4, last one, the one in red is going to be the image, and black is going to be the original. You can tell it was a reflection because if you look at T and then T prime, it was flipped down. So this is different than being flipped from left to right. This one was actually flipped down. And I'm going to look at Y here. Going to find the middle. This is going to be my line of reflection, the dashed line there. So this time we actually have a horizontal line, not a vertical line. So we're going to say reflected over a horizontal line. And our last type of rigid motion is called a translation. It is just a slide of a figure to a new location. And this is usually the easiest one to pick out. And I'll show you why. Okay, so same thing, describe how each original was translated to make the image. So pick out the image, we'll mark that one. That one's going to be blue because of the prime marks, and then the black one is the original. So when you look at this one, it wasn't reflected. You might think that it was reflected, it was flipped over, but if you look at the order that the letters are in, on the original we go from F to C. And then on the image, we still go from F to C. If I slide back up here to one of these reflections, this one, number 1, we went from K to H, and then we went H to K. So that's one way you can tell that it was a reflection and not a translation. So back down here to the translations. And also, P was on the bottom, P is still on the bottom, so that's why it's not a rotation. Okay, so you have to, all this really was is if you take your iPad and you just slide it to the right, it's going to look exactly the same. All the letters will be ordered the same. It's just slid over. So you have to make sure you start at the original. So I'm going to start at P. I'm going to start here at P, and I'm going to count how many units or blocks I slid this to the right. So this is the starting point. That would count as 0. This would count as 1. This next block would count as 2. This block would count as 3. This block would count as 4. This would count as 5. And it landed on 6. Okay, you don't have to mark each one of those. I'm just showing you how I was counted. So when you describe this, again, you have to say what type. So it was a translation. So we said translated 6 units, and you have to say the direction, up, right, left, or down. It's not enough to just say over because over isn't specific enough. Over could mean 4 directions. Okay, so translated 6 units to the right. All right, number 2, we have in blue is going to be the image, and then in black is the original. So if you look at the orientation, everything still looks the same. QU is on the top, IM is on the bottom. It wasn't rotated, it wasn't reflected, it was translated. So you always have to start at the original. That's your starting point. So if I start here at U and I count how many blocks I translated to get to U prime, it looks like this would have been the first one, 2, 3, 4. So translated up 4 units. Number 3, we have in red, we have the image, and in black, we have the original. Okay, so it's still a translation. If you see TE is still on the top, TI is still on the left, everything looks the same, it was just slid. But it was slid twice. Now the order that you do this in doesn't matter, so I'm going to go from E to E prime, and the first thing I notice is that it was slid down. So count how many down, 1, 2, so it was slid down 2, and then from there it was slid to the right just 1. Okay, so translated down 2, right 1. You could say translated right 1, down 2. The order doesn't matter as long as you have those two parts. And the last one, we have blue is the image, black is the original. So make sure you start at the original. So we're going to start at, let's say we start at L, and we're going to figure out how we translated it to the new image, which is L prime. So let's see, the first thing I see is translated to the left. So count how many blocks, 1, 2, 3, 4. So 4 units left, and then from there we went 1, 2, 2 units up. So translated 4 units left and 2 units up. And the last part of this is just combining multiple transformations. So it tells you figure ABC is transformed in 2 steps to figure JKL. Complete the statements to show which corresponding sides in each figure are congruent. So this one's a little different. We're not using ABC and then A prime, B prime, C prime. So there's 2 ways you can figure out the corresponding sides. You can look at the picture. So if you look right here, I already filled in, it says AB is, and then that's the congruent symbol, to JK. So if I looked at the picture and I'm highlighting AB in pink, what part of the picture on the triangle JKL looks to be the longest side, looks to match? It would be the side JK. So that's why I put JK. If you need to figure out what matches with CB, so I'm highlighting that in green. If you look, now sometimes they all kind of look the same. Not in this case, but if they do, another way to figure this out is if you have, and I'll write it down here, if you have A, B, C, and J, K, L, and you need to figure out what matches with CB, well, it doesn't matter if you put CB or BC, it's the same 2 letters, it's still the same side. Well, those last 2 letters match with those last 2 letters. So KL, or I wrote LK. Okay, and then if you're doing side AC, which is the last side, so AC is the first and the last letter, it would be the first and the last letter, JL or LJ. Okay, so when it tells you, when it's set up like this, ABC is transformed to figure JKL, it's telling you that ABC is the original and JKL is the image. And it told you that this was done in 2 steps. So you're not going to be able to look for one transformation and just figure out what one step. It's telling you it was 2 steps. So the first thing that I see is that it was kind of rotated. It's not kind of lined up exactly the same, and when it's not lined up the same, it's harder for you to tell what steps you need. So I know that B matches with K. They're both the middle letter. So it kind of looks like B was rotated. Okay, so if I take that triangle B and I just turn it, I said rotate counterclockwise around point A, which means you'd put your finger on point A, don't let point A move, and then just kind of swing the whole triangle around it. So I said counterclockwise. It wasn't 90 degrees, I know that, because if CB was rotated 90 degrees, it would be completely straight up and down. And it's not, it's kind of at an angle. So I estimated it about 45 degrees. Okay, so now you can imagine a triangle that looks like JKL, but it's not in the same spot as JKL. There's one spot still here at A. Now, where would A need to go to match with J? So if we have it rotated around and it looks the same, it just needs translated 2 units up. So if we translate it 2 units up, now it should coincide that you should be able to draw one over top of the other, and that's how you can prove that they're congruent, because one side isn't longer than the other.